Hi everyone, welcome to my channel. In this video, I'm going to talk about Kotlin coroutines. So we're going to go through what they are, how they differ from threads, why you might want to use them. Then we're going to go into a few components of our coroutines, so the basic stuff that you need in order to start creating your own coroutines. We're going to go into a few details about various parts that may go into your coroutines that you might want to experiment with. And then finally, we're going to implement all these concepts in a few bits of code, okay? And we're also going to do at the end a application in Android that is very, very simple, but it is designed to show you how you can use coroutines to solve a very particular problem, which is running some code, running some computation on a background thread rather than a main thread, so that you do not block the execution and you do not block the UI. So we're going to do all that in this video. Now, this doesn't cover the whole concept of coroutines by far. There is a lot more that goes into coroutines that you can study and experiment with. And if you watch till the end of the video, I'm going to give you more information about where you can find the missing information, where you can find a lot more information than I am able to provide you in this video. So with that said, let's go ahead and start talking about coroutines. Now, the main problem, or one of the main problems with threads, is that they are very resource intensive. It takes a lot of processing power, let's say, to run a thread in the background. Now, coroutines are slightly different. Coroutines are designed to be very lightweight. So they are a very lightweight version of threads. And in fact, they are so lightweight that it really doesn't matter how many you start in your code. They can work really well in parallel. And to show you this, I've put together a little program. Now, I don't want to do a hello world example with coroutines. That is very standard, everybody does that. But what I would like to show you is how we can start 1 million coroutines and have them run in parallel to print some message to the console. And you will see how easy it is to start them and how well they work together, even though we start such a massive number. So let's go ahead and do that. First of all, I'm going to use in this code, I'm going to use the IntelliJ IDEA. And the reason for that is it allows me to very easily create and run Kotlin code. Okay, so go ahead and search for IntelliJ IDEA. Okay, I'm going to put a link down below as well for you to find it. Download the community edition if you don't have it already, and open it up and start a new project. Now, when you start a new project, I already have my project created here, but when you start a new project, make sure you select the Kotlin JVM here under Gradle. Okay, so Gradle Kotlin JVM, because coroutines are a separate library. They're not part of the standard Kotlin language. So we need Gradle in order to import the library that we will use. It's very similar to Android. So go ahead and start that, create your project. I already have created mine. And then once it's built, open up the build.gradle file, then right click anywhere, click on generate, Maven artifact, and then search for coroutines here. Okay, and that should give you the latest version of coroutines. Don't worry if it's a later version than what I have here, it should work just as well. So go ahead and add that. You should have a library added here, and I'm going to enable auto import. You can also just simply click import changes if you want to import just this one time, and I'm going to enable auto import just for the system to import it automatically. All right, so we're done with the build.gradle. Now I've created a coroutines file inside my Kotlin folder. So under source main Kotlin, I have my Kotlin coroutines file. And here I have a main function, okay? So let's go ahead and put together a small program that starts 1 million coroutines. Now keep in mind, you're not gonna know everything in this program. We're gonna go through the details of what the code means later on in this video. But for now, simply put together this program as if you would put together a hello world, just to kind of get started with coding. So I'm gonna say run blocking. Okay, so you can see that that's imported our coroutines run blocking. This simply runs a coroutine in a blocking way, so it stops the current thread. Now here, I'm gonna say repeat, and I'm gonna put here 1,000,000 times. Okay, so repeat this 1,000,000 times, and here I'm gonna launch a coroutine. You can see how easy it is to launch a coroutine, right? We have the keyword launch. The reason why we have run blocking is it provides us with a coroutine scope. We will see later on what that is. But inside the launch, we are launching the actual coroutine. And here, what I would like to do, I'd simply like to print out a dot to the console. So that is all that we're going to do in this code. We're simply launching 1,000,000 coroutines that all of them print out a dot to the console. So let's go ahead and right click and run this code. Okay, it probably takes longer to actually build the code than to run it. So we can see now that the dots are being printed, and that is it. The code has finished and we have 1,000,000 dots printed at the console. So you can see how easy it is to run 1,000,000 threads, 1,000,000 coroutines in fact, and they work really well together. There are no problems with resources or anything like that. Try starting even 100 threads and you will run into problems really fast. So coroutines are really, really lightweight. And the reason for that is they actually use thread pools. So in the background, they actually run on separate threads. But the key point here is that they run each on an individual thread. And when that coroutine has finished, the thread is freed up to be used by another coroutine. All right, so the main idea behind coroutines is that they simplify async code and callbacks and synchronization, okay? So you basically run coroutine code, so parallel code, in the same way that you write and you run sequential code, okay? And you can use variables and functions that are written sequentially in your coroutine. So one of the main huge advantages of coroutines is that it allows you to access data from your main thread in your coroutine without more code behind it, more functionality, and so on. It's a very simple syntax, so as we will see throughout this video, and also we can pause and resume the coroutines at any time. Okay, we will see how we can do that, but the coroutines can be paused, can be restarted, can be resumed, can be canceled at any time, no problem. Now, let's talk about a few basic concepts, and we have a few of these here. I've listed quite a few, but in order to start coding with your coroutines, as you've seen, it's really, really simple. All we need is a scope and a keyword to launch a coroutine, and that is it. Now, the scope is basically the component that allows us to create and run coroutines. It provides lifecycle events, and it allows us to run, stop, create, and so on. Then we have the context. The context is basically the component that is provided to us by the scope. The scope provides a context, and the context contains a few components like dispatchers and like a job, things like that. We will see what those are. Next, we have suspending functions. Suspending functions are simply functions that can be run in a coroutine. The only difference between a suspending function and a function is that we have the keyword suspend before the function. Okay, so that allows it to be run in a coroutine. That's all there is to it. Now, a job is very simply a handle on a coroutine. When we launch a coroutine, we can put that handle for that coroutine in a variable. That variable has a type job, and that allows us to cancel the coroutine, pause the coroutine, and perform some operations, some lifecycle operations on that particular coroutine. Now, importantly here, there is a hierarchy of jobs. So if you have a coroutine that itself launches a coroutine, we call that a parent-child relationship between the coroutines, right? So a job can contain other jobs. And importantly, when you cancel one of the coroutines inside a job, all the coroutines inside that job get canceled. Okay, very, very important when you're dealing with multiple levels of coroutines. We're not going to go into too much detail about jobs in this video. I will tell you later on where you can find more information on that. Now, deferred is simply a result from a coroutine. Of course, you cannot have a result when you actually start a coroutine, because the main idea behind coroutines is that they run in parallel and they do their processing. So the result will be available later on. That means we can capture that result in a deferred. And the main operation that we can do on the defer is an await. So we can have the system wait for a result from a coroutine when it is actually necessary, right? So if we reach a point in our program that we cannot continue without getting a result from a coroutine, we need to wait for that result, and that is what the deferred is useful for. And then finally, a dispatcher manages which threads the coroutine runs on. So we have different threads available to us in different environments, and a dispatcher simply tells the system which thread we would prefer our coroutine to run. This is especially useful in Android because we have multiple dispatchers available to us for depending on the type of operation that the coroutine runs on. And we will talk about this a little bit later on. Of course, we have error handling as well. We will not cover this in this video either because it's a bit too much already, but again, I will tell you where you can find that information later on. All right, so let's briefly talk about scope. Now, scope provides lifecycle methods for coroutines, and it allows us to start and stop coroutines. So, for instance, we have the global scope, which is the scope of the entire application. So if you're running your code in Android, if you're using a global scope, the scope of the coroutine, so the coroutine will not be canceled unless the whole scope of our application is canceled and destroyed, right? So usually we might want to limit our scope a little bit further, okay? We don't want to have our coroutine run in the context of the whole application. We might want to have, based on an activity or even more segmented in a smaller scope, but it's good to know that the global scope is there, and you can launch a coroutine using global scope.launch. Next up, we have run blocking, which we've seen in our code. Basically, this creates a scope and runs a coroutine in a blocking way, which means wherever the program is at that time, it will block and wait for that coroutine to finish. And then we have a function to create a new scope, which is simply coroutine scope. So this allows us to create a new scope wherever we need that particular coroutine to be created. And here, it's not completed until all the coroutine children complete. So if you start multiple coroutines and multiple scopes inside that scope, it will wait until all the children have completed to be completed and destroyed. So here is an example. I do like to put all the concepts that we talk about in practice because I feel like that's the way we learn best. So here are a few examples of how you might use each scope individually. And I would like to actually put this in a small program to allow us to see how each individual scope and each individual coroutine can work. So let's go in our code here. And I'm going to comment out the code that we've put together so far. Let me make more space here. And let's go ahead and create 3 coroutines and have them print out a message with a certain delay to see how they kind of interact with each other. So the first thing I'm going to do, I'm going to say print line, program execution will now block. Okay, here I'm going to say run blocking. And then at the end, I'm going to say print line program execution will now continue. So at this point, we continue on with our code regardless of the coroutines. So inside the scope that I've created here, first of all, I'm going to launch a coroutine using the run blocking scope that we have already. So here I'm going to say delay for, let's say, 1000 milliseconds, which is exactly 1 second. And then I'm going to print line. And here I'm going to say task from run blocking. Okay, so this is the task that we have with the scope run blocking. Then I'm going to create a global scope.launch. Okay, this one I'm going to delay for, let's say, 500 milliseconds, so half a second. And then I want to print out the message, task from global scope. All right. And then finally, I'm going to create a coroutine scope. Okay, so a new scope that we create ourselves. I'm going to delay this by, let's say, 1500 milliseconds. And then I'm going to print line task from coroutine scope. All right, so that is my program. If I run this, what do you think the order of the printouts will be? So pause this video, think about the order, and then continue on. All right, so the order will be, first we're going to get this message, then we're going to block the execution. So we're not going to get this message yet because the execution is blocked. If we were to put coroutine scope here, then the execution will continue while this runs in the background. So after that, we will get the first result of our coroutines, which is the 500 milliseconds coroutine. This is task from global scope. All right, so we will get this message. Then this one will finish, so we will get this message, and then finally after a second and a half, we will get this message. And finally, after this finishes executing, okay, so when this scope is completed because all its children are completed, then we will get this message at the console. So let's go ahead and run the code. All right, so execution will now, I forgot a W here, execution will now block. All right, then we get the task from global scope, which is the fastest one, then the run blocking, then the coroutine scope, and then finally continuing on with the code, with the program. So we can see that different coroutines will end up at different times depending on the delay that we mark here. All right, so moving on. Next, we have the dispatchers. Now, the dispatchers are the last component we're going to talk about. And after this, we're going to put together a little bit of code in our Android Studio just to show you how easily you can fix a problem in an Android application. Now, the reason I want to talk about dispatchers is, like I said, dispatchers determine which thread or thread pool the coroutine runs on. And in Android, we have a few dispatchers available that are specific for different types of tasks. So the common dispatchers are, the first one is main. Now main is only available in the context of an Android Studio, or I should rather say when Gradle defines the main dispatcher, that's when it is available. If you try to run the main dispatcher in your IntelliJ IDE without defining it, then you're going to have a problem because it doesn't really know what it is. In Android applications, the main thread is the UI thread. Okay, so it's very, very important and very useful. That's why we will put this code in Android Studio and not in IntelliJ IDE, because we will need to use this main dispatcher. Now, we also have the default dispatcher, which is useful for CPU intensive work. We have the IO dispatcher, which is useful for network communication or reading files. Okay, and then we have an unconfined dispatcher, basically starts the coroutine in any inherited dispatcher that was called. We also have a new single thread context dispatcher. This one is used to force the creation of a new thread. This is not very useful because it makes you have to deal with threads themselves, which is kind of the point of coroutines, that it allows you to disregard thread management and focus on code. Okay, so you can use this if you want to. I wouldn't recommend it unless you really have a use case that requires it. All right, so with that said, let's go in our Android Studio where I have prepared for us a program, a little application and I'm going to explain to you what this application does. Okay, so you will find the code or the GitHub repository for this application down below in the description if you want to try it out yourself. So what does this do? It's quite simple, really. So we have a function in our main activity. We only have one activity. We have a function called generateNextPrime, which simply generates a prime number. Okay, we have a variable at the top here that says current prime, and every time we invoke this generateNextPrime function, the current prime will be updated with a new prime number. Okay, so this will increase with the execution of this functionality. Next up, in our onResume, we have a for loop that runs exactly 99 times, so from 2 to 100. It generates the next prime and it updates the UI with the current prime. Okay, let's have a look at the UI. The UI is quite simple. We have a spinner that allows us to see that the UI is responsive. And then up here, we have a text view that simply displays the latest number. Okay, so this one will basically update the UI 100 times, or rather 99 times. Okay, and then we will see the number at the end. Now, the reason I have built this application is that if we run this in a continuous loop, you might expect the prime number to increase while the spinner is running. But since we are executing this code on the main thread, that will not happen and the UI will be blocked. So what I'd like to do, I'd like to run the code as it is here, okay? Just test it out to see if it works. If we stop at 100, then we're going to run it in an infinite loop, okay? And we will see that the UI actually blocks because this is executing in an infinite loop. And then we will see how we can solve this problem to have the number updated, have the responsive UI, while at the same time running this code in the background to not block the execution of the application. We will do that with coroutines. But first, let's try it out as it is here. I'm going to run the code, and then I'm going to skip the video to where the application has started. All right, so we can see here that the application has started. We have the spinner that is running. Okay, we can see it being updated. We can see that the loop has finished. So the 100th prime number is 541. So everything is running as expected if we do not continue to do the processing in the background. All right, now what I'd like to do, I'd like to leave this in an infinite loop. So I'm not going to just count 99 prime numbers. I'm going to want to let the system keep on calculating prime numbers and updating the UI. And if I run this, you will see that the actual UI is blocked because the background processing is done on the main thread. So let's have a look at that. All right, so there we go. The UI is not being updated. Okay, the main thread is blocked by the execution of this function. All right, so let's fix this problem and have the execution go in the background using coroutines and allow us to update the UI so that we can see all the numbers that are being generated. So the first thing we need to do is we need to create a scope. So right here before the while loop, I'm going to say coroutine scope. Now inside the coroutine scope, I'm going to pass dispatchers dot default, okay, because I want to do some intensive processing, dot launch, and I'm going to put everything inside my coroutine scope. So now that we have this will run in the background. Okay, so very, very simple. We simply launch a coroutine with a scope that we define, we provide the dispatcher, and everything should run in the background. The only problem we have here is that we still need to update the main thread, the UI thread, and we cannot do this from a background thread. If you run this code right now, it will crash because this is trying to update the UI. Okay, so at this point, we need to move to the main thread in order to allow us to update the UI. So how do we do that? It's quite simple. We're going to say coroutine scope, and here we're going to pass the dispatchers.main.launch, and then we're going to pass this inside the launch. All right, so let's go ahead and try to run this and see the outcome that we get. All right, so we can see now that it is working as we were expecting, right? So we have our UI that is being updated. We have the numbers that are being generated and updated here. We have a responsive UI, so we have solved our problem in a very easy way with coroutines, right? Importantly, two dispatchers here, dispatchers.default and dispatchers.main. Let me stop this execution here. All right, so that is all I wanted to talk about. One quick tip, instead of coroutine scope here, you could also use the keyword with context, or the function rather, and here you use the dispatchers.main. This is a sort of a shortcut to launch a coroutine by switching the context of this coroutine scope. Okay, so it's really up to you. Again, we're not going to go into too much detail. I promised you I would tell you where you can find more information. Now, of course, there is the official Google documentation where you can find a lot of information. So I will link that down below in the description as well. If you want something more accessible and easier to understand with real-world examples, I have created a course that is dedicated to coroutines. It has more than 10 hours of coroutine specific content, and that includes applications in Android to show you how you can use it with various components, right? So like MVVM or retrofit or other things. So I have linked that down below in the description as well. So have a look at that. I've also included a promotion, okay, a promo code to give you a large discount on that course just for the viewers of my YouTube. All right, so that is all for this particular video. Please leave a thumbs up if you like this video. It really helps the YouTube algorithm promote my video to other people that might be interested in finding out about coroutines. And finally, thank you for watching, and I will see you soon.